Well, good evening, everybody, and welcome to another OC CTOs event. For those of you that it's your first time here, I'd like to give you a little bit of context on our group before I introduce to you our guest speaker of the night. But Orange County CTOs is essentially a local CTO group that we run. Essentially started actually a year ago this week, so it's our first year anniversary. We've been running ongoing meetups every month. Yeah, thank you. And essentially the mission of the group is to bring technologists, technology leaders, people that are running the technology agenda for fine Orange County companies, come together. Sometimes we just get caught up at work, we're stuck in our buildings, we're doing our thing, and then we don't get to interact with our peers that could potentially be sitting in the office next to us or very close by. So we thought of putting together this platform, and essentially what it is we run open meetups every month that are essentially open to the community. We try to get as many CTOs, VPs of engineering, just technical leaders in the room to share a little bit of that. Sometime in this year, we actually started to do a little bit more private, intimate meetups as well, and Dave was actually part of those as well. And we actually just get a group of people, grab appetizers and drinks, and just chat. We've been running that successfully as well. We're going to pick those back up. But essentially that's it, right? If you're a CTO in Orange County and you don't have the time to go up to the LA CTO forum or down to San Diego to hang out with our buddies at 7 CTOs, we didn't have a lot of options here locally, so we started it, right? We are in growth, so if you have friends or anybody that would benefit from such a group, please do help spread the word. We're on social media and we do all the website things and whatnot. Without further ado, I'm going to introduce to you our speaker for the night. So Dave is an experienced technologist focused on evolutionary product development in the enterprise, small business, and consumer markets. He is presently Director of System Software at CTO Group here at Western Digital. By the way, thank you for hosting us, WD. Here in Irvine, where he leads engineering teams in the creation of new products. He has also served as Chief Architect for WD Labs, where he drove IoT initiatives, proof of concept projects, and technology partnerships conducive to WD's innovation product offering. Lastly, at WD, he built a software development team that delivered several new products to market on Linux, Windows platforms, including the #1 selling consumer NAS network attached storage in the world, as well as the #1 selling Windows storage server essential appliance, all within the WD My Cloud unit. David has also had senior hands-on engineering positions at Dell, EMC, and Toshiba. He's an active member of OCCTOs and contributes his thoughts over the open and private events. Believe it or not, David has actually been in OC area all of his life, so I just learned that today. So anyways, without further ado, Dave Cohen.
Thank you, Marco. And that was an excellent recitation of my LinkedIn profile. Thank you. Should probably update that. Welcome to my home. I hope you enjoy the beer. You are actually slacking on the beer. You're going to have to pick up the pace because I don't want to have to carry it all home. It could, I don't want it to end up like that big fight that they had over at the Anaheim Hilton last weekend. You hear about that, the big beer convention they had. They had some big brewers convention and all the beer companies were there, and I guess the CEO of Coors was at the convention. He's in the bar at the Hilton with his staff, and they're kind of rowdy, and so he goes up to the bar and very obnoxiously yells, "Bartender, give me a silver bullet!" And so the bartender gives him a silver bullet, and his team cheers, yay, right? And so the CEO of Budweiser happened to be right next to him. And so he, more obnoxiously and more loud, happened to walk up to the bartender, and he says, "Bartender, give me a Bud Light!" And his team, erupts, and they start having words back and forth with the chorus guys. And so the CEO of Sam Adams, our beer of choice tonight, walks up to the bartender and very loudly and obnoxiously says, "Bartender, give me a Diet Coke!" So the CEO of Coors, of course, can't let this go. And he says, "Well, aren't you going to have a beer?" And the response was, "Well, if you're not going to have a beer, well, I'm not." So And then there was the big fight. So before we get started, I want to just hit a little bit on, who my team is and what my team does at Western Digital. You can tell by the bio, we've changed roles a couple times. WD Labs was the previous iteration of our group. Currently, we are the emerging systems and software team. So in the CTO office of Western Digital, there are several research groups. Now, we are all research groups, very non-product focused, by the way. But we have some teams that are staffed with material physicists and with chemists, and they are focusing very much on new types of memory and new types of storage and how is that going to work. And then our team actually takes a different approach. We take the top-down approach. So we actively seek out partners for exploring use cases. And we take those use cases and we apply that, we learn all that we can, and we apply that learning against the different technologies that we're exploring within the CTO office. So as an example, one of our partners is the Treehouse Childhood Cancer Initiative. And they have a workflow that they package in a Docker container, and they ship it to hospitals all over the world. And the purpose of this workflow is it will identify from a patient's RNA, from a child's RNA, about 400 different strains of childhood diseases and cancers. And the thing about childhood cancers are, especially in newborns, sorry to do this while you're eating, by the way, but the thing about childhood diseases, especially in newborns, is that the child's body is changing so rapidly that they do much more damage and much more rapidly, and every minute counts. So to run this workflow, to run this pipeline, it takes between 14 and 40 hours. And those 14 and 40 hours, especially for a newborn, are excruciating. So our goal as a team is to take that time and reduce it down to minutes. Now, it is very pompous and irresponsible for us to believe that we are going to come into an area like genomics, where you've got 50 years of science, brilliant scientists who are working on these problems and say, oh, we're going to look at your code, we're going to fix it all up, and you'll be fine. Because they actually do have some of the best software engineers in the world working on these problems. Our approach is to engage with the teams, deeply embed, spend as much time as possible, understand the problems that they're trying to solve to the level of being conversant with them, and then start to have the discussion. If you had the architectural choices that you have today, when you put together the pipeline to begin with, what different design choices would you have made? What different opportunities would they have been? So that's just one example of the types of partners that we take on. And we've got partners in fintech, and we've got particle physics. We actually have a proposal out with CERN in Switzerland, the CERN Open Lab. And my personal favorite is we have a proposal out with the National Park Service to predict the cherry blossom bloom in the National Mall, to figure out what day they're all going to be in bloom so that they can schedule the annual Cherry Blossom Festival. Now, generally I get that kind of response, like, okay, who cares? So let me rename that project for you. Using satellite imagery and geospatial weather data and internet images to predict a repeatable biological event. So now the learning that we do in there, we expect to apply to crops and migration and all kinds of different problems. So we actively seek out the world's biggest data problems and just embed ourselves in to try to understand what's going on. So that's our team. One of my hopes is that a couple of you today will have an opportunity, a big data problem that you're working on, that you're trying to solve, and will approach us and say, hey, we would like to partner and we would like to help you learn. Because honestly, that's what our organization is all about as a true research organization. Now, that's a little painful for me because, as you can tell by what Marco said, my entire background is in products. In fact, one of my product managers is sitting right in the middle of the room there. So I don't want to say that I preferred the product mindset, you got a date, you got a product, you got to ship it. However, the research mindset is very different, and building that kind of team is very different. So let's get started and start talking about RISC-V. Some of you might have noticed a lot of press lately around RISC-V, especially coming out of Western Digital. You might be wondering what RISC-V is. You could be wondering, why is Western Digital involved with this at all? And you should be wondering, if you care. Today I'm going to try to answer those questions for you. I'm going to give you the current state of the RISC-V ecosystem, and give you an idea of what tools and opportunities there are going forward. But by participating in the RISC-V ecosystem, you will have new tools in your toolbox to solve your stakeholders' steepest challenges. So, our safe harbor statement. I am a big non-believer in reading slides to people, so I'm not going to read this to you. What it actually means is that any of the statements that I make today on behalf of the CTO's office will likely change tomorrow, depending on factors that have nothing to do with me. So, I think they were going to summarize it as, don't listen to Dave, but just didn't have the right tone. So what is RISC-V? One of the most basic definitions of RISC-V is an open and free instruction set. So we get into these debates with other developers and other engineers all the time. They say, okay, RISC-V is open and free instruction set, so what? We've got open source operating systems, we've got open source all over the place. Why is this any different? The difference is that actually the IP blocks and the instruction set for the processors is open source. You can go out and get them today on GitHub. And in fact, they're free. So if you compare that to, say, ARM, there is no $50 million buy-in to start working on a chip. You can start working on your chip tonight at home, just off of GitHub. Another definition of RISC-V, or another way to look at it from the engineering staff perspective, is the opportunity to iterate hardware design. So this is a theme that you'll see in the RISC-V community over and over and over again, is that wouldn't it be nice if you could design your hardware using the same type of processes that you use to design software? Small incremental changes, small iterative changes, accepting other people's design and incorporating them into your products as well. Product managers would probably define RISC-V as control over custom I/O and peripherals, and being able to use custom peripherals. So today we are all locked into the predefined ways that memory is connected. We are locked into the world of shuttling bits between storage and memory and how we talk to our peripherals. Well, with an open instruction set that is extendable, now you can talk to custom peripherals, you can talk to custom buses, and you actually get to make the decisions on how do you get the bits in and out of the processor. My personal favorite way of looking at RISC-V, when I talk to my team about RISC-V, we talk about custom accelerator development. Talk about custom interfaces from the application needs on down. So tying back to being the use case team, tying back to working with scientists in different fields, what we try to do, or what the opportunity that RISC-V offers us, is the ability to have custom interfaces all the way down to the bare metal, where we can decide which level of the stack, where does the acceleration happen, and how is that implemented. So all these definitions, all these different ways of talking about RISC-V, they all start and stop with the open and free instruction set. So that's the mantra. You're going to hear me say that over and over. I apologize. But we know from software that sharing provides tremendous scale in innovation and adoption. But sharing in open source has specific implications, and it all goes back as businesses, as CTOs, to the licensing. We know that for the licenses, if you want to have a community and you want to build interaction and you want to build openness, well, the copyleft licenses will do that for you because they're going to force you into sharing your innovations with the rest of the community. However, what we know is that the permissive licensing that we see really drives a tremendous amount of the business today because companies like ours do have to protect their core IP. So on the open source licensing schemes, we're not quite there yet. I know that Western Digital Legal and the RISC-V community are haggling right now over different types of licenses and where you should use each one. And clearly the code that's available today and the designs that are available today have licenses associated with them. But I think it's going to be a while because software licensing derives from a genealogy of copyright. Right? It all comes from copyright type of behavior. And hardware licensing really does, even open hardware licensing, really does derive more from the patent perspective. And by saying so, I am deliberately and cowardly avoiding the concept or the discussion of software patents. Absolutely. But it is the design lifecycle which speaks to the licensing model. And even internally in Western Digital, as we talk a little bit about some of our own core IP designs, we want to keep some IP blocks protected. We want to be able to be open and available on the core technologies and the RISC-V implementations. So I guess all I'm trying to say is that the licensing, fair enough, we've got plenty of work to do there, and there's a lot of iteration, a lot of evolution that has to happen with hardware, open source licensing. So now some of the tools that the RISC-V ecosystem can add to your toolbox should be coming clear as we talk about IP blocks and open designs. But at the core here, why is Western Digital involved? Why are we engaged in this? Well, we are clearly one of the world's largest storage companies, and we don't produce processors, and nor will we. There are no plans in Western Digital to become a processor vendor or become a processor business. Well, one of the reasons why Western Digital is engaged in the RISC-V ecosystem is that our customers are pulling us. You may not realize this, but half of the world's data today lands on Western Digital devices. And in that data, we need to focus on bringing the processing to the data where the data lives. Now, what's interesting about that, what our customers are noticing is that a tremendous amount of the data that lands on Western Digital devices is what we call dark data. You don't know what, you're not really sure what's there, what's not there. You're not really sure how to retrieve it and how to do something with it. And you certainly, a vast majority of the data there, we don't have a clear understanding of how to monetize it. And at the end of the day, migrating from a storage company to a data company, it's the monetization of the data that we are trying to facilitate for our customers. So our customers are pulling us into this RISC-V ecosystem. So let's take a quick moment and talk a little bit about the history of data and where it came from. Well, originally, we all remember when data was records. It was banking transactions, it was records, it was ledgers, it was relational databases, and soon thereafter it became communication. Email showed up, voice over IP, data became our primary communication, and even today it still is. However, something interesting happened recently where data became efficiency. It became functional efficiency. So I realized getting from the front door to this room was quite a feat. That notwithstanding, I am willing to bet that nobody in this room used a Thomas Guide map to find the building. Because when you use your phone or your device, or you're using Google Maps to find, to navigate you through traffic, you're actually getting real-time information on traffic and patterns and blockages and so forth. So data in that way becomes efficiency. And where we know we're going is data is currency. We can completely ignore blockchain and Bitcoin, because that would be the easy argument to make, right? Data is currency. However, what we do know is that if you include the telemetry information in your car to your insurance company, you're going to get a discount on your auto insurance. And likewise, if you install the proper water sensors and smoke alarms in your home, then you get a discount on your homeowners. And certainly, if you allow Southern California Edison to turn off your air conditioning at times of peak power, they will give you lower energy rates. So data becomes a currency. Our customers are demanding value from their data, and they are demanding data from the value from their data immediately. Which brings me to my next point. When you are valuing data, there is a temporal value. Newer data is more valuable than old data. So we all have in our storage systems, we've got backups, we've got cold storage, we've got warm storage, we've got hot storage, we've got memory pools that we're acting from. And all of those are ways of representing the temporal value of data. Consider gunshot detection. Gunshot detection in a city, you've got microphones around the city, gunshot is picked up by some of the microphones, they're able to triangulate and pick out where did those shots come from. If that data arrives in a week, it is not valuable. If that data arrives in minutes or seconds, it is valuable. So the temporal value of data is pushing us off of some of the traditional storage devices and more towards memory-centric architectures and memory-centric compute. So our thesis, as it is that we can look at data as big data and fast data. Oversimplification, yes, but we're not concerned with the great general purpose compute in the middle that most of us are dealing with every day. What Western Digital is most concerned with is the big data applications where you've got the large pools of data that you want to learn from posthumously, and the large pools of data that we consider fast data that you want to learn from immediately. Imagine an autonomous vehicle driving through traffic, coming up to a railroad crossing, and it's got to send all of its data up to the cloud to figure out that there's a freight train 50 feet in front of it. That is perhaps a big data application and a misuse of technology. However, I suggest it would be short-lived. The fast data response is to process the data at the edge. So we've all lived through recently everything's going to the cloud, we're going to the cloud, we're going to the cloud, right? And now it's, well, some things should be processed at the edge. Some data needs to live at the edge. So our oversimplified thesis is there's a fundamental difference between big data and fast data, and the way the operations and the interactions that we have with them, and the value of that data. So along with the lovely animated graphics here, restating the obvious, big data with insights, analytics, reporting, fast data with performance, real-time results. I love the fact that they put the camera on this. Amy and I, in our previous iteration at Western Digital Labs, W Labs, we actually got to work with and meet the team that used video analytics to follow the backpack from the Boston bombing, the Boston Marathon bombing. And they're the ones who actually used video analytics and multiple data feeds from multiple different quality cameras from multiple different angles, and were able to trace that backpack all the way back through the crowd to who brought it in, and where it came from, and where they went. And if you remember how that story ended, within 24 hours, there was a full-blown manhunt for the appropriate people. And when they found them, they were absolutely certain they were the right guys, and behaviorally, they validated the point. So another reason why Western Digital is engaged with RISC-V ecosystem is that our devices are locked to the same traditional architecture that your notebook computers are. The general purpose compute architecture, with its pre-established limits on how much memory you could have, with the number of lanes you get to your storage, those are all determined by people at companies who are trying to sell massive amounts to the average consumer, and general purpose does hurt. And so what we're trying to do is move beyond general purpose. So please indulge me as I beat to death another analogy. If you compare general purpose compute to a four-door sedan, four-door sedans are nice, lots of people use them, they get your family where they need to go. However, if you have more specialty needs, like shipping or perhaps space flight, the four-door sedan is not going to suffice, unless it's a Tesla, in which case space flight will suffice. We have the same problem within our devices itself. Frankly, before I got to Western Digital, I didn't realize that every single device has got the same computer architecture. It's got a processor, it's got some memory in there, it's running code, it's shuttling bits between RAM and the storage media. Some of the characteristics of that data is highly partitionable, highly parallelizable. You can work on large sets of problems on small sets of the data. For example, genomics, right? Highly partitionable data. Big data problems. On the fast data side, more of it's got to be contiguous data. It is not partitionable. It is a large memory space. So consider a in-memory database or perhaps a large graph. Right? So traversing a large graph. What RISC-V does is RISC-V allows us to get away from the interconnects and the traditional roles of compute, and allows us to create custom accelerators along any part of that path, and actually shorten some of those data routes. So last year, Western Digital committed to migrate our cores to RISC-V. We ship over 1 billion cores a year. We expect in the next year or two to double that. And we are committing to move all of those to RISC-V. So we went ahead and we built a team. We have 2 cores under development. We're going to get into what those look like in just a moment. It's either a small and a tiny and a small, or a small and a medium, depending on what your day job is and what your perspective is going to be. And we committed to have our first products based on RISC-V delivered to the market by early 2019. And we do report that we are on track to meet that goal. So let's take a brief look at the development that we're doing under the hood. So our first RISC-V core has got a 9-stage pipeline four ALU engines, and what we discovered was the core part. So fun is a euphemism for easy, right? So we found out that the core part was not where the work was, but getting the data in and out of the chip, in and out of the core, that's where all the work was. I see some of you smiling and nodding, because I guess that is always the case. But as a multi-purpose SoC inside our SSD applications, what we really are doing is we are taking advantage of the fact that with RISC-V, we have control over how many NAND channels we use. We can have more or less NAND channels. We have our own ECC engine, and how that connects to the core, we have total control over. So now we have custom instructions in our core for free from the RISC-V ecosystem to deal with the idiosyncrasies of flash, to deliver as many channels as we want. And this actually relates back to the conversation we were having, right? And at the same time, give us a direct pipeline, a specialized pipeline into our very own ECC engine. So another one of the reasons that Western Digital is involved in RISC-V is this whole new world of memory-centric compute. It's driving the need for storage class memory, persistent memory. And what we've already done is started to benefit from our own decisions on NAND and ECC, and putting memory on fabric as opposed to having dedicated memory. So we are well on our path to facilitating large pools of memory with multiple heterogeneous processors, some of which are accelerators, some of which are more general purpose. They might be GPGPUs, they might be FPGAs that are programmable on the fly. But it's the interconnects that the traditional architectures don't give us. It's the data path that we are able to change and modify using the RISC-V ecosystem and tools. So those are the reasons why we are so heavily involved and so heavily invested in RISC-V. So from our perspective, RISC-V does help us address the needs of both big data and fast data. As far as the big data, computational storage, I'm going to say that a few more times so that next time I don't forget it. Which is funny because that's one of my pet projects right now. So, with computational storage, where you move the processing down to the storage, somebody else in here was talking about they've got customers saying, gosh, can I get some of the processing down into the device? Well, what does that do for you? Well, what that does for you is there's three places where you benefit. Number one is data ingest. So on data ingest, now you can have something more intelligent inside the device that's laying out the data in a way that's more useful for your application that's going to use it. When the data is at rest, you can do garbage collection and cleanup and all those things that we like to do. What's interesting is today, Microsoft is pushing an initiative, Open Channel. How many of you have heard of Open Channel? Excellent. Well, what Open Channel basically does is they're trying to push the commands for flash maintenance, for wear leveling and whatnot, up into the operating system. Not all of it, but the ability to start and stop garbage collection and any of the maintenance operations that we do. Why would they do that? So that their applications that they are running at their levels can make sure that we are not getting in the way and they don't have phantom slowdowns that they don't understand coming from the device. So they get to choose the time and place in which these maintenance operations run. But the third place, the final place that you really benefit from computational storage is on query, when you are fetching the data. So today, if you have an array of SSDs that have some data on it that you want to query and you with high selectivity, right? What you would do is you have to copy all that data up into your processor, up into memory, and pipeline it through and look for the records you want and then hold on to the ones you want and then ignore the rest. Well, with computational storage, it would go something like a custom command down to the device saying, give me this data, and then you only get back the data that you need. So bandwidth is preserved. You're doing your processing where you have the maximum amount of bandwidth within the device, and your functionality is greatly enhanced, and your performance goes way up. Every decision we make in Western Digital is somehow tied to cost, performance, or real estate, which is a function of cost and performance. Right? On the fast data side, it is the concept of attaching storage class memory to fabric, where you never have to flush, you never have to copy off to storage unless you're archiving for long term. It's a whole new tier of storage that behaves like memory, perhaps actually byte addressable, right? Or a whole new tier of memory that behaves like storage. Either way, what happens in your software up at the level that I care about, my team cares about, at the application level, what happens when you no longer have to worry about when your data is being flushed and when it's not being flushed, because it's in memory, it's in persistent memory, and it's always going to be there. We have opportunities now for sharing memory between processors, carving up work on the same pool of memory, attacking large graphs and for fluid dynamics, astronomy, some of the larger data point problems and the relationships between them, right? So those are our perspectives on the data environments that our customers are pulling us towards and the opportunities that Western Digital sees that are made easier and made accomplishable by RISC-V. So let's take a look at your business. Let's take a look at your stakeholders and the problems that you're trying to solve. You can fall into the big data or fast data. We've made these overly generic terms, so everybody should fall in part of the tent. And my personal favorite here is, of course, machine learning, because inference and the training part is a big data problem, and yet the execution and doing something with learning is a fast data problem. So there's no reason why you have to pick sides. You can play on both sides of the fence here. Even densely integrated storage devices, the fact that you've got your peripherals all on board, you're densely integrated, and you need to manage your internal data paths, so forth. RISC-V gives you the opportunity, because it's open and free, and because it is you have iterative development. Now you can have the interfaces that you need to make your devices possible. So I'm going to switch gears over to where the ecosystem is today and what tools are available. And I'm going to apologize because these next set of slides are kind of a laundry list of what the ecosystem is and what developers have. We go through this. I'm going through this, and I chose these slides for this audience particularly because what I would like to see, what I am hoping, is that some of you decide to engage with RISC-V. You decide to go to GitHub, download some of these sources, take advantage of some of these opportunities, and join the community and contribute with us. It can't be just WD driven. So the fact that we've committed a billion devices to the market is a good start. However, our hope and our dream is that everybody forgets that Western Digital did it because it's a large and thriving community. So some of the tools that are available to you today are, of course, a variety of kernels and the Debian distro. So, of course, the Linux kernel, Cell4, RTMS, RTOS environments as well, Apache Minute, Zephyr. Debian Linux is also available for RISC-V today. It's unofficial and unsupported. However, the good students at UC Santa Barbara have got 80% of the packages building. So you say, what's missing? Well, what's missing is some of the debug tools and some of the profiling tools. So if you are trying to do profiling, those are the tools that are following on now that are just coming online. But take a look at this adoption curve. So engineers, You just can't trust them. So these dates are the year and the percentage through the year that the date occurs. So you've got roughly June back to April. So we went from 35% of the packages on RISC-V, and this line here is RISC-V, the RISC-V adoption of packages in the Debian distro. So we went from early April with 35% of the packages supported to about May, 80% of the packages supported. And we even passed some of the other architectures as far as Linux package availability. Some of the tools that are available for the RISC-V ecosystem are the standard build tools, languages, and even some IDEs. So, of course, GCC, or would we be without GCC, and GDB, and glib, and so forth. Even Java, Go, and Rust are available for RISC-V today. The development IDEs accompany Sci-Fi for their first development board. There's a Arduino compatible Hi5 board. It's about $50. It's got all the same pins as Arduino, and you can actually build from the Arduino IDE for the RISC-V chipset. It's also integrated with Eclipse. They call their version Freedom Studio, and our particular favorite brand, because our CTO is friends with the CTO of that company, Platform.io, which is a plugin available for Visual Studio Code and Eclipse. Some of the other tools that are available on the RISC-V ecosystem are, of course, cores, chips, SoCs, and simulators. So here is a shopping list of cores that are available. Chips that are on the market and available today. SoCs that you on the market available today you can build with. In fact, one of these, we have a project with the Ministry of Education in Israel to build the core STEM education system for software development and hardware development for elementary school students on RISC-V. They're using the RISC-V platform for that. And there are several RISC-V simulators, and I want to point out the QEMU, which is a fully functional QEMU. So practically, what do you do with this today? The first thing that comes to mind myself, going back to my product roots, is I say, well, that's nice, so I can design my own core, I can build it iteratively, I can get the open source, and it's free. What do I do with that? Because at some point, I got to build a chip. And how do I build a chip? Well, that is part of the ecosystem today. So a company called Sci-Fi has a service called Design Share, where you have a web-based development environment. You drag and drop, literally, the IP that you want for your cores. And then what they do is they will combine your design with other customers, and they will put that on a wafer, and they will produce the wafer for you. So in a short time, literally a couple of months, at a very low cost, $10,000 to $100,000, you will have a prototype of your own custom chip with your custom interfaces, with your custom instructions, ready to go. So I haven't personally tried it. I want to. I have to write a check to do that. But it does speak to the goal of modeling the hardware design and iteration as efficient and as you see with modern software development. So the goal is to get hardware innovation as community-driven and as accessible as software development is today. So these are the tools that are available today. This is what the ecosystem looks like today for the RISC-V ecosystem. So Western Digital is clearly actively contributing to and benefiting from the RISC-V ecosystem. It has changed the way that we design products. It's giving us higher performance. It's giving us greater density. It's giving us far greater control over the way our devices work, lowering cost. We've been out supporting the development of open source IP. We've been helping with license development out in the field. We're actively partnering and investing. So many of the companies that you saw, Western Digital actually invests in those as well, because we're investing in companies that are helping the ecosystem grow. So our goal is to accelerate the development. We believe in purpose-built processors. We think that the general purpose compute world is well served, well understood, and is mature. So we are off on the edges for purpose-built, big data, fast data applications and solutions. So this transition isn't going to happen tonight. It's not going to happen by the time you find your way back to your cars. If you find your way back to your cars, it will be a multi-year transition. But we are fully committed to the adoption of the technology. So we talked about what RISC. We covered a lot. Right? I like hearing myself speak, so sometimes I lose track of how much we talked about. But we talked about what RISC-V is. We talked about why we're involved as Western Digital. We talked about why maybe you should care, and we extended the invitation to join the ecosystem. We actively invite you to join the ecosystem. And hopefully you see it, by participating in the RISC-V ecosystem, you will have new tools in your toolbox that will help you solve your stakeholders' steepest challenges in solution design. With that, if you have any questions. My goodness, I was thorough. Well, thank you very much. Please finish the beer and pizza, and don't forget to tip your servers on the way out.
All right, good chat. Let it not be said, I have not learned new things just in the last 30 minutes. So thank you, Dave. I appreciate it.